take into consideration in the observable universe, and it being like 14 billion light years again, or 14 billion light years, or 14 gigaparsecs. Essentially, what we're looking at is that we have what is known as superclusters of galaxies, and there's said to be at least 10 million that I was able to find, at least the highest number I've ever seen. And it's also estimated that with those supercluster of galaxies, just one supercluster can be anywhere between 500 million light years. Keep in mind, a supercluster is a bunch of galaxies that are together, and then it zooms out. Well, it's like there's a couple different subclasses. There's a galaxy, there's a bunch of galaxies, then you go into what is known as a cluster of galaxies, and then there's a bunch of super cluster galaxies, and then you zoom out even further, and it's another like a super cluster of galaxies. It's a little confusing, but once you really understand like how the subgrouping goes, like like putting a box in a box in another box, you understand how science is very organized and how it portrays itself. But anyways, it's awesome though, it really is. Like, I think all these things that we don't know about, that like it truly is infinite, endless. You can't just, like, for example, you can't just look at the universe and say that just because you don't see anything that's truly what you see. No, I mean, it's out there. It's all these things are out there. So think of it like this. 500 million light years is 500 million times 3.26, and essentially 500 million is half of 1 gigaparsec. So that's essentially 1/28 of what the universe is, or the observable universe is, in diameter, which is pretty crazy when you think about it, because 500 times 28 would give you 14 billion. And when you think about that, that's pretty crazy. That's something that big can exist. I mean, you look at Earth, for example. Let's go back. Let's just kind of go and look at a smaller estimation. Earth is said to be over 7,919.5 miles in diameter. Most of it is 2/3 oceans, or just water in general. Over where I live, there's the Great Lakes in Michigan, and I'll be honest, I'm 6 feet tall. But when you apply that to how big the Earth is and how big, it seems like it's even bigger than what we give it credit for. And when you look at the pictures that are taken from outer space, you really have to ask yourself, how big is the planet in reality, and how much can you really do on this planet? How many things have happened in the past? How many mysteries have we not solved? But then meanwhile, there's all these other planets that are out there that you just don't even see them, and we never will, but it's like they exist though. And it'd be vice versa, because it'd be like, imagine like there's a group of aliens that exist like on an uncharted alien planet that we never even seen before. Maybe they don't even know we exist. And yet, we look at all these things and we wonder how big they really are. Or take the sun, for example, which is right there. I mean, I'm not going to point the camera at it, but the sun is out there. And, it's said to be 1.3 million times bigger than the Earth, and it's 150 million kilometers away from the Earth, or 93 million miles. Or we could say, if we wanted to put in perspective an astronomical unit, or if we wanted to say that the sun is bigger than the Earth, then essentially you would take, if we wanted to say how big the sun was, we could essentially say that if we were to go 1.3 million times bigger than 7,919.5 miles, we could essentially say that that's how many Earths could fit in the diameter of the sun. I'm not sure if you want to consider the mass as well. I think that'd be something completely different, but but it'd be really interesting though. You look at like all these things we don't know, and just how many, like for example, like my philosophy is, if I find something new, I make a video about it. I could make thousands and millions of videos I wanted to, just talking about this stuff. And I just think that it really surprises me that some people don't find science as exciting as some people do, like Carl Sagan or people like Albert Einstein or Nikola Tesla, even though he was an engineer. And you know, you look at someone like, what was his name? Not just Albert Einstein, but I'm trying to think of his name. He was a famous... Oh, geez. I forget his name. I really do, and I can't believe I can't remember it. Anyways, you know, you had Albert Einstein, you had Carl Sagan, you had, like, well, someone like George Carlin, even though he was really more of a comedian, he wasn't really much of a scientist, but he was somebody that, well, he wasn't a licensed scientist, but he was like an individual that seeked, like, and he was educational. He was trying to inform people, you know, don't believe what people tell you, but, and he would always say that, you know, he looked up at the universe, and some of the things that, you know, George Carlin would say, like, for example, if you never watched George Carlin, you know, go watch his videos on, like, you know, religion, and, like, he'll talk about how, you know, like we humans have been doing it wrong all these years, and I mean, again, he's not the only one that came to this conclusion, obviously. I could tell you the same thing, but you know, when you look at the universe, humans cannot just summarize it in the way that we tell ourselves. You know, the point that I'm making with these videos is every time that, you know, I come out and I say that this is how big something is, or this is how, you know, the universe is bigger than what you and I could comprehend it to be, let alone it's more complex than it looks. You know, there's things we can't see. There's, like, for example, different dimensions. And they're so far away, too, that, you know, where do you really draw the line? Like, here's another really good question, though. You know, where would you draw the line that you're now entering the third to the fourth dimension, for example? You know, how far is the third dimension from the fourth dimension? You know, I bet you even Stephen Hawking, that's the guy I was thinking of. You know, even he, and even people like Christopher Hitchens and all that, you know, they would bring up really good points that people just don't understand science because they look at it and they say, some people would say that they just don't care for it. And therefore, you know, they wonder why people look at them and they say, well, you know, you can't say the things that you do about science because, unless of course it's true or it's based off information. And if there's people that are willing to state that the universe is, like, they don't believe it's like older than 6,000 years old, well, clearly these people aren't looking at some of the videos that I'm even making, aren't jumping to conclusions that I am. Because when you really think about it, you know, okay, nobody's perfect. Of course, people are going to be inaccurate and wrong, but hey, the closer you are to it, the more correct you are, and you know, there's a huge difference. You know, accuracy is my point in this video, but when you really look at, like, how big, like, the universe is, there's no way any human being could rationalize it. You know, just like the people that, you know, they can't prove or disprove a God, and it's the reason I'm an agnostic. You know, you have to be open-minded to everything, but at the same time, though, we can't just accept anything and then just say it's true. You know. Unless, of course, there's a really good reason behind it. Because when you think about it, you know, the universe is bigger than, again, not just bigger than what we think it is, but it's older than we are. There's been stuff that happened before we did, but no human being has any track record of that. But that doesn't mean it doesn't exist. Again, like Carl Sagan said, absence of evidence is not... I forget always how he says it. It's like a tongue twister for me, but it's, you know, like absence... Or was it Christopher Hitchens? I forget exactly who stated it. But, you know, just because people say that there's no evidence now, that doesn't mean that there's never been any evidence for it. Like, for example, like, you know, let's say that there's a God that exists, okay? That doesn't mean that, you know, the idea of a deity doesn't exist. Maybe they're from another dimension. Maybe, I mean, you know, let's try and rationalize this. If we died right now, and there was an afterlife, but it wasn't any of the gods that people worshipped on this planet, it would, you know, that doesn't mean they wouldn't have existed. That just means that, you know, it would have just been something we've never heard of, something we had yet to understand, and that makes sense. But at the same time, though, you know, if they're not, though, let's say that something like this never really did exist, like there are no deities, and then, you know, then the question would really become, where, like, how would you really look at the universe? Like, you know, you don't necessarily need a creator, sure, but now the question would be, if an individual didn't make the universe, maybe the universe itself created itself somehow. Because, you see, the idea is that, you know, the more you study science, the more you learn, the more perplexing and the more of a paradox it becomes. Because some people will argue that the more you know, the more like plot twists that you notice. Yeah, plot twists. That's what I'm trying to do. It's like somebody writing poetry about the universe. You know, that, you know, like take black holes for example. You know, anybody who reads black holes, they usually think of Stephen Hawking's work, and you know, he's a really intelligent fellow. You know, he has to, you know, he's onto something. He's got to be onto something every time he publishes something he comes out with. You know, it's just who he is. So, like, when he started saying that stuff like, you know, black holes aren't really what they look like, you know, people started really asking the question, then what are they really, and where do they go? Is it a gateway to another dimension? And if it wasn't for the fact of the intense pressure that kills you before you get in there, you know, where does it really go? You know, it's interesting. It really is. Like, these questions that, you know they exist, but it's like, what are they really, though? Because it's a question that begs an answer. It really does. I mean, you know, yeah, they destroy stuff and they convert things back to their normal stats. But it's like, you know, thankfully we won't run into them anytime soon. But it's really interesting to think about, you know, how the universe really works. So the gravities, the accelerations, the forces, unknown forces, just all these different ideas that just push the boundaries of what we know. And you know, when you learn something new, it really takes the record for being like the greatest thing we've ever learned, or even the most perplexing argument that just really, you look at that and you're like, how does that work? Like, how does that make sense? And then, you know, then this is where science comes in, and a bunch of scientists do a bunch, you know, scientific method. They conduct a bunch of experiments. They state, hey, you know, this is how this works. And then, you know, eventually people just, they learn new things. And then they publish their findings. And, you know, okay, they don't have to always be 100% right, but, you know, but they're onto something, though. And then, therefore, you know, they, you know, depending on if it's a theory, depending on if it's a hypothesis, depending on if it's conclusions or accepted as fact, you know, everything, you know, maybe everything doesn't necessarily happen the same way every time, but, you know, but at the same time, though, you know, it does. Like, for example, you know, like, whenever there's a fire, okay, so how do you put a fire out? You use water, because that's just how it works, you know, and, you know, you put the fire out, you know, makes sense, you know. It's the law of nature, you know, fire burns things, water drenches things, and then it just becomes steam afterwards, and things turn to ash. Fire just turns to smoke. Well, I mean, well, where there's smoke, there's fire, but, you know, like when you drench something, you know, the time that the fire's still burning, but then you see, like, all this, you know, it's like steam. Well, depending on, well, it depends. But it can just, it turns into, you're essentially putting the fire out, and, you know, it's going to smell like fire. It's not like burning, but not like a candle, like where you burn like a wick, and then the wax, and then it smells like the way it does. But like when you put a fire out, though, there's smoke at first, and then there's like all the steam that comes out of it. Depending on, well, I guess it depends on how you really do it, because I mean, there could be fires that are so hot that, you know, it doesn't really look like there's anything after it. It just burns everything. But the idea is that that's just the physics behind it. The elements, the chemistry, chemical, physical change. And, you know, it's just one of the many things that you commonly see. You know, people get rid of stuff, they burn it. You know, our cars burn stuff in order to, I mean, but it doesn't start a fire, though. It just kind of, I mean, it's flammable, yes, but it's not going to start a fire, like, immediately. You know, our cars just, you know, so we can start our cars up and we can go somewhere. You know, and the universe is like the same thing. You know, there's endless cycles, and they all work differently. But the reason why the universe is infinite is because, like, you know, there's so much out there. It's getting bigger, and yet it evolves differently. And at the same time, though, when you think about it, you know, just because we don't see it doesn't mean it doesn't happen. So when you think about how big the universe is, it's always got something new to offer. And it always has been that way, because humans don't know everything. But at the same time, though, the universe been here longer than we have, and, you know, you really got to ask yourself, though, what's been happening that we don't know? Because that's a good question. You know, the universe is been around longer, yes, and the universe is stronger than we are. So what how many universes are there? What is the meaning of life? What happened here? Is the question that's usually on everybody's mind when even if they don't really realize it yet, people are always asking that question. What is the meaning of life? Why does the universe exist? Why does everything happen the way it does? And that's where science comes in.